Very good morning. This is in continuation to video 9 on two-way ANOVA. Here we'll be doing exercise 9, question 1. Let's read the question first. A researcher investigated the impact of gender and cell phone usage on driving performance. Each of the 24 people, 12 males and 12 females, who agreed to participate in study drove a car on a closed course where their driving accuracy was assessed. Driving accuracy was measured on a 0 to 50 scale with higher score indicating better driving performance. While driving on the closed course, half of the participants, 6 males and 6 females, spoke on a cell phone, while the other half did not. The data are provided in this figure. So we have gender, cell phone, and driving score of 24 participants here, where gender is 1 for male and 2 for female. And for cell phone, 1 is spoke on the cell phone and 2 didn't speak on cell phone. So that's there. We have to enter the data in a SPSS file and perform the appropriate analysis to answer the questions. We have to name the variable, gender, cell phone, and driving score. We have to state the null and alternate hypothesis for each test of interest. We have to state a research question for each test of interest. We have to test for assumption of equal variances at alpha is equal to 0.05. We have to test main effects of gender, cell phone, and for gender interaction with cell phone using alpha is equal to 0.05 for each test. And which test, if any, are significant. Which test, if any, are not significant. That is, we have to answer. And then E part, we have to report the effect size for each of these tests. Which of the test has the largest effect sizes that we have to report. And finally, we have to write down the result of the study. So that's the case here. So coming to the SPSS file for just uploading the data. So here we have recorded the data in the SPSS file where the data for the 24 respondents has been recorded. So this is data view. Coming to variable view, we have got the 3 variables. Variable 1 is gender. So we am saying gender of a respondent. So we know we have to say 1 for male and 2 for female. So I'm giving the label. So I've added that. Coming to 2, that is female. We have added that 2. Okay. And then we know this is basically a nominal scale. Coming to variable 2, which is again independent variable, is talking about cell phone. So that is the, so talked, sorry, spoke or did not speak on cell phone while driving. So that is there. And then values we have to say. One is for drove, spoke on cell phone, spoke. Let's write only spoke to didn't speak. So this is what I'm writing, the adding it. Okay. And then the measure is again nominal. Third one is driving accuracy. So this is the name of the variable. So I'm saying driving accuracy, and then the values are not mentioned because we know the value is between 0 to 50, where 0 is or lower values means less accuracy, higher value means higher accuracy. The measure happens to be scale. So this is how you can say the values have been, you can say, put up the variables being created, and we are prepared for the test. But before we move to test, let's look at the initial questions which are talking about hypothesis formation and your research questions. So coming to the questions now, talking about the A part of the question where we have to frame the null and the alternate hypothesis. As talked to you previously, in case of two-way ANOVA, we have three hypotheses. The first hypothesis is for independent variable 1, the second hypothesis is for independent variable 2, and the third hypothesis is for interaction between the two independent variables. So independent variable 1 here happens to be gender, and we are talking about male and female. We are basically trying to see if there is any difference in the driving accuracy of males and females. So the hypothesis will be that mean driving accuracy level for males and females are equal in the population. That is hypothesis null 1, where mean of males is equal to mean of females. Similarly, the alternate hypothesis 1 is mean of male is not equal to mean of female. So that is the null and the alternate hypothesis for independent variable 1. For independent variable 2, which is cell phone, where people either spoke or didn't spoke when they were driving. So the null hypothesis for the cell phone states that the mean driving accuracy for those who spoke on cell phone and those who didn't spoke on cell phone are equal in the population. This means that hypothesis N2, mean of spoke is equal to mean of not spoke, whereas the alternate hypothesis states that two population means are not equal, meaning um, hypothesis A2, mean spoke is not equal to mean not spoke. Similarly, test of interaction for gender and cell phone, that is hypothesis 3, the null hypothesis is that there is not gender cell phone interaction, and alternate hypothesis 3 is that there is gender cell phone interaction. So that is about the hypothesis. Coming to B part, we are talking about the research questions. We have framed the three research questions for gender. The research question is, does the respondent does the reported driving accuracy differ among males and females? For cell phone, does the reported driving accuracy differ for those who spoke on cell phone and those who didn't? And for interaction of gender and cell phone usage, the research question is, does the reported driving accuracy for gender depend on whether the cell phone was used or not? So that is about the um, you can say the A and B questions which are theoretical in nature, and now we'll be moving to a SPSS file for analyzing the answer. So we are moving to the SPSS file. So this file I've opened for you. We are now conducting two-way ANOVA. For that, we go to analyze and then we do the tests. So we go to analyze. I click on analyze. I've got something called general linear model. I'm clicking on that, and then maybe you can say univariate variable. This particular you can say box opens before you. We have got two independent variables, gender and spoke or did not spoke, which is fixed factors. Driving accuracy is dependent variable. We move to EM means, where we are clicking on gender, cell phone, and gender and cell phone. By this we'll be getting, you can say, mean values and standard deviation for gender, cell phone, and gender cell phone interaction. So that's there. I'll simply click on continue. I move to options. In options, I will click on descriptive stats, which I'm getting, effect size I'm getting, and homogeneity test I'm getting. So this I'll continue, and then I'll go for plots also, where I'm trying to plot, you can say, gender in horizontal axis, cell phone in the separate line. And remember, you can say I can even put cell phone as horizontal axis and gender as separate lines, because both these variables, gender and cell phone, happen to be, you can say, two category variables. Gender as male and female, two category, and similarly you can say cell phone again as two category, spoke and did not spoke. So that being the case, We'll put anyone in the horizontal axis and separate axis. But had there been a case where cell phone was having three categories, or even gender was having three categories, and the second variable was having only two categories, in that case, the variable which was having three categories will be placed in horizontal axis. So that's the case. Here I'm simply adding, I'm continuing, and then I'm going for um, I'm just going for plots. I'm just saying I've done the plots. I've done it then. So I'm just going for OK. The moment I click on OK, my output file opens. I'm sharing the output file with you all here just to see. So the output file is now open, and there it is. We have got the output file now here with you. So just the univariate analysis of variance, two-way ANOVA has been conducted. We have between the subject factors, gender is 1 and 2 for male and female. We had 12 each of male and female. Similar people who did spoke or did not spoke while they were driving were 12 each. And then we have got 24 respondents in all. Descriptive stats is coming up as for male, spoke didn't speak. The mean was 33 and 44 respectively, with standard deviation of 3.22 and 2.60. One thing we are getting is that male driving accuracy is quite large between those people who spoke or didn't spoke, and they being male. Whereas for female, you can say those people who spoke and didn't spoke, the driving accuracy was 30 something and 45 something. The mean score with standard deviation of 5.2 and 4.4. And we see, you can say, differences again almost in the same region, sorry, same way or same range for males and females as far as they spoke or did not spoke. Coming, you can say, to Levin's test of equality, if you look at the values here, you will find that driving accuracy based on mean, the value of Levin's statistics come to 2.471 with a significance of 0.91. So we are believing that the equality of variance is there, and therefore you can say we know that both the samples are coming from the same population. Now coming to the test between the subject effects, where we are going to see that, okay, fine, which hypothesis we are going for, alternate hypothesis to be accepted or null hypothesis to be accepted. So if you look at gender here, for gender, you can say the value of, you can say, F is 0.310, quite low. And of course, the significance is again 0.584. This means that there is no difference between males and females and their driving accuracy. When it comes to cell phone, here you can say the value of f happens to be 61.634 and a significance of 0.000. This means there's a significant difference as far as the people, you can say, who either spoke or did not spoke while driving the car and their driving accuracy. So that's a big you can say a yes to alternate hypothesis coming up. Similarly, for gender and cell phone interaction, we see the value of f coming to 1.357 with a significance of 0.258. This means there is no significant interaction taking place between gender and cell phone, and therefore we see that, okay, fine, the the range or differences, you can say, for either, you can say, those people who spoke or did not spoke in using cell phone, you can say, while driving, the things, or you can say the values, do not differ much as far as males and females are concerned. Coming to the estimated margin means, we have got, you can see, the value for gender. So males about 38, female for 37. So the accuracy level is not much difference between you can say males and females, with a standard error of, you can say, 1.163 both for males and females. Similarly, for people who spoke or did not spoke on cell phone while driving, for spoke, the mean is 31.59583, whereas for the people who didn't speak, the accuracy or driving accuracy was 44.50. So if you look at the things here, the difference, you can say, in driving accuracy to people who are speaking and not speaking is quite high, and which has been proved as significant also in the analysis we have seen just a moment before. And then maybe you can say, coming to the male and female, and then talking about, you can say, driving accuracy for those people who spoke or didn't speak. You can say the values are 33 and 44 for males, which means a huge difference. Similarly for female and male, female who spoke or didn't speak, the values are 30 and 45, and maybe you can say a bit different to that, 30 something and 45 something. But then the range possibly happens to be same for males and females, and this has been seen when we were talking about, you can say, the interactions also. So we do not see much of a significant interaction as far as male and female is concerned. And now talking about the profile plots. Here we are talking about the, you can say, the two, you can say, values which we have taken up here. So we know that when we are, you can say, looking at the profile plots, so male and female, well, fine. For maybe you can say, for those people who spoke, as far as male and female is concerned, you can say the driving accuracy of males who spoke was much better than, maybe you can say, driving accuracy of females, you can say, who spoke when they were driving. And similarly, you can say the driving accuracy of males also was a bit better, who spoke, you can say, while driving, to females, you can say, sorry, I was talking in a wrong way. In case of, you can say, males, you can say, we find that the driving accuracy is less for males who, you can say, were driving and simultaneously, you can say, speaking on cell phone, than females who had, you can say, you can say, spoken during their driving. So if you look at the things, we find the differences there. But as far as the interaction has been seen in case of gender and driving accuracy for, you can say, those people who spoke or didn't spoke, you can say, using cell phone during driving, we don't see much of difference. And therefore, you can say, for gender and for cell phone, interactions are not coming in a very significant way. So that was for the answer here. So moving back, I'm moving to the actual SPSS file where we'll be talking about the answers. So if we look at the equality of variance, the C part of the question, equality of variance is assumed at Levin's test of equality of variance at, this answer I've mentioned is a bit wrong, because the actual answer happens to be 2 point, let's move to the output file here. So we have the answer. The actual answer happens to be, um, 2 point, okay, let me see it here. So the actual answer happens to be 2.4 2.471. So let's move up here and change the answer. So 2.431. So that's the answer we are getting. So I'll be, you can say, opening that answer, 2.471. So we'll be having that answer only in our, you can say, 2.41. So the answer basically is 2.2.417. So 2.417 is the answer, and significance is 0.01. So things are fine here, and therefore what we are seeing is that, okay, equality of variances, you can say, is assumed at Levin's test of equality of variance at 2.417 and significance of 0.091. So that's one thing we are having here. And then test for mean effect. So here we are talking of, you can say, the hypothesis, the three hypotheses we've seen. For gender, there is no significant difference in the driving accuracy of males and females. So we are accepting the null hypothesis at a value of 0.31 and p is greater than 0.05. Similarly, for cell phone, what we find is that there is significant difference in driving accuracy of people who spoke on cell phone while driving than who did not. We accept the alternate hypothesis at f is equal to 61.63 and p is less than 0.05. And finally, for gender and cell phone interaction, there is no significant interaction between the two variables. We accept the null hypothesis at f is equal to 1.357 and p is greater than 0.05. So that was about the D part. Coming to E part, the effect size. And when we are talking of, you can say, effect size for two-way ANOVA, we are actually calculating partial eta square, where we are just trying to see the effect size. So the formula here is eta square or partial eta square is equal to SS effect upon SS effect plus SS error. So sum of squares effect being divided by sum of squares effect plus sum of squares error. And for gender, the value is coming to 0.051, which is quite small. So actually, you can say the effect size is negligible. As far as cell phone is concerned, the partial eta square is coming to 0.755, which is quite high. I would call it, you can say, high. And then we have interaction, where you can say the partial eta square happens to be 0.063. So again, it's quite low. So that is what the effect size is. Now we are coming to the final answer, how the answer is to be written. So look at the way the answer has been put up. A 2 cross 2, because we had two, you can say, uh, categories for gender and two categories for cell phone. So I'm saying 2 cross 2 between subject and over was conducted with driving accuracy as dependent variable and gender, male and female, and cell phone, spoke, not spoke, as independent variables. The result indicated that there was a no significant effect for gender. F is 1 and 20, that is the df1 is 1 and df2 is 20, is equal to 0.31, p is greater than 0.05, and partial eta square is equal to 0.015. With males, m is equal to 38.50 and sd is equal to 3.22, and females, m is equal to 37.58 and sd of 4.47. But there is a significant main effect for cell phone with f degree of freedom 1 is 1 and degree of freedom 2 is 20 is equal to 61.63, p is less than 0.05, partial eta square equal to 0.755 with those who spoke on cell phone while driving. M is 31.58, SD is equal to 1.163, reporting significantly less driving accuracy than those who didn't speak. M is equal to 44.5 and SD is equal to 1.163. And similarly, talking about, you can say, this interaction between gender and cell phone, we do not see any significant interaction taking place at f is equal to 120 is equal to 1.357. P happens to be, you can say, greater than 0.05, and partial eta square is equal to 0.063. So that is summing up, you can say, the A, B, C, D, E, and F answers of this exercise 1. I'm enclosing exercise 2 for you to solve. So you go through this exercise, you can say, you have the SPSS file, work on that, look at video 1, which is the example video, video 2, which is the exercise 1 video, to attempt, you can say, video, sorry, attempt, you can say, exercise 2 of the given, you can say, exercise. So thank you for your, you can say, your attending this session, and being, you can say, a very serious, you can say, listener. So thank you.